updated those numbers just now on the file systems assignment. How many of you had to go do this gobbledygook? This GPT convert to DOS? Yeah.
I haven't yet.
Did it work?
Yeah.
Okay.
I think so.
Gotta make sure my instructions still work. Who
I
knows?
still have dev STA1 is of 1 megabyte, and I thought I deleted it, but it's,
Okay.
I just don't care about it.
Well, it seems like I had to delete that.
I thought I did delete it.
Oh, if you did delete it, then.
I'll just delete it again so it happens.
Okay, so the new partitions that I want you to create, since we had a different space amount than last time. So you create after the initial install, then you'll have a 6 gig primary partition for the root file system. You'll have a 512 megabyte partition for RAM. There's 2 of your 4. And then I'm going to have you create another primary partition of 200 meg. And then an extended partition of a gigabyte or 1,000 megabytes. And inside of that, you'll create 10, 50 meg logical partitions. And then on side of that, to format those logical partitions, 4 of those logical partitions will be formatted as ext file systems, 3 will be formatted as VFAT, and 3 will be formatted as an NTFS. And you'll see here, like this particular one, I want it to be formatted as ext with a block size of 4096, no reserved blocks, and 128 inodes. How do we do that? Read the man page. And really you don't have to read the man page, you just read the top line of the man page. So if I do man, MKFS, ext4, you can figure it all out right here. So reserve blocks, that's minus M. I want 0% reserve blocks. 128 inodes. So I look over here for something about inode. Inode size? No. Bytes per inode? No. Number of inodes, right there. So I want 128 inodes. So you do minus N. So you can look through this, at least the top part of the man page there, to figure some of those things out. There is a possibility, now that I've changed all the sizes, that we might have some unheard of errors that I haven't heard of yet. But we'll see how it goes. Just leaving these numbers the way they are. Hopefully it'll be okay. And then, so once again, step 1 is you're creating the partitions using cfdisk. Step 2, you're formatting the file system is using the MKFS command. Step 3 is you're going to mount the file systems. So I said, let's create a directory on /space. Inside of this directory, create 10 directories to mount the directories listed above. These 10 directories will be mount points for the 10 file systems. Put entries in etc/fstab for all of these file systems we've mounted at boot time. Manually test them, then reboot the machine to verify boot time mounting. But remember, what happens if you mess up etc/fstab and then you reboot? Your machine is no longer bootable, and you can't get back and edit anything. All right. So we went through some slides last time that showed how you would use the cfdisk command, how you'd use the MKFS command, how you'd use the mount command, how you'd edit etc/fstab, and how you'd test those.
Here's a question.
Yeah.
It says up there we need to make 10 50 megabyte files. I don't think that would work partitions because we only have 1.5 gigs and we're already taking 1 gig, 200 megabytes, and then another.
But remember, the logical is inside of your extended.
Okay.
Yeah.
I thought it said something else.
Okay, so once you have all those partitions mounted and ready to go, the next thing you have to do is exercise those file systems. So the other day when we did system resources, you went and downloaded memhog and CPU hog. But also in that directory were 2 other programs, or 2 or 3, called disk hog and inode hog. And all they do is disk hog just uses up, creates a bunch of files until it fills up the partition disk space. Inode hog just keeps creating new files until it uses up all your inodes. Remember we said there's two different ways of running out of space. You can actually use up, allocate all the blocks, or you can use up all the inodes. So that's what they're doing. Now, be very careful. If you run disk hog on your root file system, what will happen?
It'll fill up completely and then you will just die.
Yep, death. That's right. So you want to be careful as you, after you mount your file system, you want to CD into, make sure you CD into that mounted file system and you run these programs. Now let's see, did I take any screenshots of that? Oh yes, I did. They're over here at the end of file systems too. They're like right, I think we ended on that last time. All right. So here is, I'm on my file systems machine. I'll do a wget. I'll download those resource hogs like we did the other day. You'll extract them. So now we have all these: CPU hog, disk hog, file IO hog, inode hog, mem hog. And we'll move those over into user local bin. We've done all that. Okay, so I made a note here. We could do our tests in any of our new partitions, but make doubly sure you're not in your root partition or you will fill up your disk and a horrible death will ensue. The other thing to be aware of is, let's say I'm in this, can you guys tell right there? Is that path, is that in my root file system or is it on partition? Can you tell from looking at that?
No.
You can't tell. So here's another issue that I've seen students have is they create etc stab, they create the partitions, they create the directories, and then they start running the inode hog programs. But they have not done the mount command or the df command to make sure that this is really mounted to the new partition. And if it's not mounted to the new partition, you'll be running these commands on your root file system and fill it up. So just make sure that they're actually mounted to these paths before you do it. All right, so I'm inside, and this is one way of looking at that. So notice I do a df dot. What does df mean? What does it mean? Disk usage, disk free. How much disk space do I have free? So if you look on my current working directory, it shows that I am mounted at dev SDA8. So that's the partition that this is referring to. Good. If it shows dev SDA1, that's a problem. That's my root file system, and we don't want that. And okay, so I'm only using 1% right there at that point. So disk hog, you can read in the README file a little bit about disk hog. And if you run disk hog -h, it gives us the help page for this. Pretty much all we need to know is to run disk hog, you can, if you want to, pass in -f and then a name. So basically, if I do disk hog -f garbage, it's going to start creating garbage 01, garbage 02, garbage 03. It's just going to create a bunch of files till we fill up all the blocks of our hard drive with disk hog. And right here, I have students ask me, oh, is it supposed to do this? Error in write. Why do you suppose it said that? Can't write anymore. Ran out of space. That's what we wanted to say. We wanted to eventually fill up our hard drive till it can't fill up anymore. So that's good. And then, if I do the ls -la, great. It shows, what's this? Just a file, I guess, that it just kept writing. I guess it's a single file in this one, but it's one large file until it maximized the space on that. I thought I ran the df command, but that's wrong. Oh, right here. So now if I do df command, it shows that SDA8 is at 100% capacity. Okay, we filled up that partition. Awesome. I can go and remove that file now, bring it back up. And then look at inode hog. Inode hog creates many small files until no more inodes are left. There might still be disk space, but we've exhausted our number of inodes. So if we run the inode hog minus h command, once again, all these hog programs, you can't Google for them because they're just scripts that we wrote. Anyway, so it says how many files per directory. The default is 1024.